Chris Packham, Associate Professor of Physics and Astronomy at UTSA, has collaborated on a new study that expands the scientific community's understanding of black holes in our galaxy and the magnetic fields that surround them. We discuss this, and we speak with a recent graduate who was able to observe a black hole using a unique airborne telescope called SOFIA.
A black hole is really the end stage of a star. If there's a large star, it can explode in an event called a supernova, and the remnants of that, the core of the star, can collapse down such that not even gravity can resist the collapse, and it collapses down into a black hole. A black hole is really a star that becomes incredibly dense, it's very massive, and not even light can escape. It's that massive and that dense. Once material gets close to a black hole, it gets entrained by its gravity and it really can't escape. It's only got one direction it can go, and that's to fall into the center of the black hole. But the way it falls into a black hole isn't directly towards the center. As you can see on this diagram here on my left, you can see that the material kind of spirals in. As it spirals towards the black hole, the material begins to exert a lot of friction against itself as it's spiraling in. That friction makes things extremely hot. And what we can see is we see that material around the black hole. Of course, a black hole is a black star against a black sky, but what we can see is the signpost of that black hole being the disk of material that's falling into the black hole. So when we say that we're observing the black holes, typically we mean that we're observing the material that's just falling into the black hole.
So we actually study the environment around supermassive black holes in a specific type of galaxy. And the supermassive black holes at the centers of these galaxies are actively eating material. So there's material actively infalling onto these supermassive black holes. And so we took some observations using a telescope called SOFIA, which is an airborne telescope. So it's a 2.5 meter telescope that is on board a Boeing 747. And the reason that NASA decided to do that was because a lot of low energy wavelengths can't penetrate the atmosphere. And so by putting a telescope onto an airplane and flying at 40,000 feet, you can get above about 99% of the water vapor in the atmosphere that prevents ground-based observations. The telescope actually sits on this kind of gyroscope, and so basically when we hit turbulence, it looks like the telescope itself is bouncing, but in all actuality the telescope is being completely still and the plane itself is bouncing. The black holes that I study are actually a few 100 million light years away, and so they're extremely small, and they're actually surrounded by dust, so we can't directly see these black holes. And so what we study is the dusty environment around the black holes. And so even though SOFIA has a relatively good resolution, the resolution still isn't good enough to completely resolve this dust.
It's become really exciting in the last few years. Nowadays we can work with people around the world. So this study was led from the University of Florida, involved people from Spain, from the UK, from Japan, from Texas, and of course myself here in San Antonio. So we can work together in a very collaborative way. The internet has really changed things enormously. Nowadays, we can work in a collaborative team to really harness the skills of people around the world by using Skype or FaceTime or any other internet kind of a communication tool. We exchange large amounts of files with each other. Everything's about collaboration. One thing that I love about astronomy is that it's a fascinating subject for me in itself, but now we work with people around the world. That's a very nice side product that we can work with people in various cultures and get to know them.
Well, to me, astronomy and astrophysics was just the most interesting thing that I could possibly study, and so for me it was just a need to know, like, how does the universe works and how did we get here?
My goal as a professor here at University of Texas San Antonio is to bring that excitement of collaborative science here to San Antonio.